Hi, I'm Safra Aftab, and I'm one of the 6 fortunate Master of Electronic Engineering students who have secured work integrated learning placement at Ceramic Oxide Fabricators, Bendigo. Ceramic Oxide Fabricators is an Australian-owned and operated company with more than 45 years of history in the manufacture of zirconia and alumina-based ceramic products to a large number of high-temperature treatment industries across the globe. The mission is to supply robust and simple and entirely ceramic oxygen sensors. Currently, I'm working as an engineering scholar at Ceramic Oxide Fabricators under the supervision of the General Manager and my supervisor, Peter Crowhurst. I have worked on carbon potential analysis using the zirconia oxygen sensors with my colleagues. The work helps the company to understand theoretically regarding the carbon potential in the carburization industry. On the basis of our mathematical findings regarding the carbon potential analysis, we were able to develop an online carbon potential calculator that is now online available at the Australian Oxide Systems official website. The aim is to help the customers to choose appropriate oxygen probes regarding their temperature conditions. And I'm glad to tell you that the calculator has already been appreciated from the customers from Sweden and New Zealand. Currently, I'm working to develop a flow valve for reference air. The flow valve will supply air from room temperature to a high temperature oxygen sensor. The special feature is the wide flow range, that is of 50 milliliters per minute to 5 liters per minute. In order to develop a flow valve, there are various factors to be considered. One of the most influential factor was the forces that affects the flow of air and the float movement. After developing the mathematical model for the forces that affects the flow rate and the factors that affects the movement of the ball float, then I have measured the aperture of the needle valve and the weight and the size of the ball float. After all this, I have suggested what should be the requirements for the assembly of the flow valve. After that, I have created a geometrical model in SolidWorks and performed a CFD, that is the computational fluid dynamic analysis, using SolidWorks. SolidWorks is an incredible software that allows the user to design, model, simulate, and test a part according to the real conditions. My work has been appreciated from the supervisor and has been selected as the best poster at the IT and Engineering Showcase at Trobe University. My design flow valve will help the company to fabricate a new product for its customer and will help the company's economy to grow. When you start designing a new product, there are many challenges waiting for you. One of the obstacles for me was to develop a mathematical model, as finding authentic source from the literature review is complex to develop a new design. Another challenge was understanding how the software works. Learning a new software is a time-consuming task, and the software like SolidWorks has so many features to deal with. Another challenge was the testing of the design part according to our conditions, as the flow valve is designed for the room temperature conditions. All the problems were encountered by the help of my supervisor, YouTube tutorials, and the literature research. Wheel placement has been an amazing opportunity for me in terms of learning new skills that falls under the criteria of Engineering Australia. While working on the carbon potential analysis, we have applied mathematics and the numerical analysis to develop a mathematical model, and we have validated our work by plotting graphs between temperature and millivolts to validate our findings using MATLAB and Excel. Understanding SolidWorks was far much easier as I have completed my computer-aided designing course during the bachelor's, and I had a good hands-on practice on AutoCAD. Through my completion of the Design for Manufacture course in my Master of Electronics Engineering program, I have studied how production of a part is being done and what are the factors that affect the production of any of the product. While working on the flow valve, I was more concerned about all the environmental factors that could affect the working of the flow valve and the material that should be used in order to produce a high-end product with less production cost, yet a promising quality. Throughout my bachelor's and master's degree, I have worked on multiple projects that includes the production or developing a design on AutoCAD or developing power supplies, C language codes, or a control systems or PCB or schematics. The most basic approach to initiate any project is to inquire about the requirements it requires. For example, for developing a program on C language, we need to identify what libraries should be used, and if we are developing a product or a circuit, we should be knowing that what components should be used. I believe that I conduct myself in an ethical and professional manner by being honest to my job and the people I work with. I'm always punctual at work and follow a good communication with everyone I work with. I avoid the circumstances that can result in conflicts and may affect the people at the workplace. I always try to finish my work before the deadline. I'm always ready to learn new things. I have developed a good teamwork skills while working on the carbon potential calculator along with my colleagues. Also, as a solo worker while developing a flow valve for the reference here. These skills will help me to work in a diversified workplace where I can efficiently work on my own or in a team, where I can implement my engineering skills such as proposing designs, modeling, simulation, mathematics or numerical analysis or the literature review professionally. One of the most important things that I've learned throughout my will placement is to not to be scared of learning new things and how much it is crucial to validate your work by peer review or literature review, such as the designing or the modeling and simulating at the SolidWorks. With reference to my experience as ceramic oxide fabricators, I would like to suggest few things to the future students that are going to undertake will placements or making themselves job ready. Always focus on the concepts you have studied during your master's or bachelor programs and make sure that you understand all the concepts really well. And most importantly, be honest to your job and the people you work with. Never give up on your assigned tasks and follow the hit and try method, and don't forget to validate your work with a peer review. Also, always have a positive attitude to learn new things or new skills and never confine yourself to specific skills. Lastly, I want to thank my colleagues, my supervisor Peter Crowhurst and the Work Integrated Learning team at Trobe University for providing me with this remarkable opportunity of Work Integrated Learning placement at Ceramic Oxide Fabricators, Bendigo, for developing new skills and making myself job ready. Thank you.